Our universe is vast, an almost incomprehensible expanse that stretches beyond the limits of our imagination. It's filled with billions of galaxies, each teeming with stars, planets, and cosmic wonders that we are only beginning to understand. And around many of these stars we're finding planets, exoplanets, worlds beyond our solar system, that could hold the key to answering one of humanity's oldest questions. Are we alone in the universe? The sheer number of stars and planets suggests that somewhere out there, on a planet bathed in the warm glow of its own sun, life might exist. These distant worlds, with their unique environments, could harbor life forms that are completely different from anything we have ever seen. Maybe, just maybe, a planet like our own Earth, a place with blue oceans, green forests, and an atmosphere that sustains life. Since the first exoplanet discovery in the 1990s, we've found thousands more. Each new discovery brings us closer to finding a world that mirrors our own, a twin Earth in the vastness of space. Each discovery fuels our curiosity about the possibility of finding another Earth, a place where life as we know it could thrive. Scientists and astronomers are tirelessly working, using advanced technology and innovative methods to scan the skies for signs of life. Could there be another planet with oceans, continents, and an atmosphere that allows us to breathe freely? The search is on, and with each passing day, we get closer to finding the answers. We've sent robotic explorers to our neighboring planets, uncovering evidence of past water on Mars and the possibility of hidden oceans beneath the icy shells of Europa and Enceladus. These discoveries hint at the potential for life in places we once thought were barren, but our sights are set even further, on planets orbiting distant stars. The quest to find another Earth is a profound one, driven by our innate desire to explore and understand the cosmos. The quest to find another Earth is a profound one. It's a journey that takes us to the farthest reaches of space, pushing the boundaries of what we know and what we can achieve. It's a search for life as we know it, for a planet that could be a second home for humanity, and for answers to some of the biggest questions we can ask. Are we alone? What is our place in the universe? Is there another planet out there that's capable of supporting life? The universe is vast, and the possibilities are endless. Our journey of discovery has only just begun. In our search for another Earth, astronomers focus on a special region around stars called the Habitable Zone, often referred to as the Goldilocks Zone. This zone is where conditions are just right, not too hot, not too cold, for liquid water to exist on a planet's surface. Liquid water is essential for life as we know it. It acts as a solvent for biochemical reactions, transports nutrients, and helps regulate temperature. A planet too close to its star would be scorching hot, its water vaporizing into space. A planet too far away would be frigid, its water locked away as ice. The habitable zone's location depends on the star's size and temperature. Larger, hotter stars have habitable zones farther out, while smaller, cooler stars have habitable zones closer in. Finding a planet in the habitable zone is a good starting point, but it's just one piece of the puzzle. Even within the habitable zone, a planet needs the right atmosphere, the right mix of gases to support life. Our own Earth's atmosphere, with its nitrogen, oxygen, and trace gases, provides the perfect balance for life to flourish. Red dwarf stars are the most common type of star in the Milky Way, making up about 70% of all stars in our galaxy. They're much smaller and cooler than our Sun, often only about a tenth of its size and mass, and they burn through their fuel much more slowly, sometimes taking trillions of years to exhaust their hydrogen supply, giving them incredibly long lifespans, far exceeding the current age of the universe. This longevity makes them intriguing targets in the search for life, as their stable environments could allow life to develop over extended periods. However, red dwarfs present unique challenges for habitability, which scientists are still trying to fully understand. Because they're cooler, their habitable zones are much closer in than the habitable zone around our Sun, often just a fraction of the distance. Planets in these close orbits are susceptible to tidal locking, where one side of the planet permanently faces the star, creating a scenario where one hemisphere experiences perpetual daylight while the other is plunged into eternal darkness, much like how the same side of the moon always faces Earth, a phenomenon known as synchronous rotation. This tidal locking can lead to extreme temperature differences between the day and night sides of the planet, with one side scorching hot and the other freezing cold, making it difficult for life to evolve and thrive, as the conditions are harsh and unpredictable. The close proximity to the red dwarf star also exposes these planets to intense stellar flares and coronal mass ejections, which are bursts of radiation and charged particles. Bursts of radiation that can strip away a planet's atmosphere over time, leaving it barren and exposed to the harshness of space. One example is Kepler 186f, a planet slightly larger than Earth that orbits a red dwarf star about 500 light-years away in the constellation Cygnus. While Kepler 186f resides in the habitable zone, where liquid water could potentially exist, its close orbit and potential tidal locking suggest that life might have to adapt to harsh conditions, such as extreme temperature variations and high radiation levels, perhaps finding refuge underground to escape the radiation and maintain a stable environment for survival. Proxima Centauri b is the closest known exoplanet to our solar system, orbiting the red dwarf star Proxima Centauri, a mere 4.2 light-years away. This proximity makes it an enticing target for future study, but it also faces the same challenges as other planets orbiting red dwarfs. Proxima Centauri b is likely tidally locked to its star, resulting in a permanent dayside and nightside. The amount of radiation it receives from Proxima Centauri is still debated, with some studies suggesting it might be too harsh for life as we know it. However, the possibility remains that Proxima Centauri b could have a thick atmosphere, or a magnetic field that shields it from the worst of the radiation. Only further observations and perhaps one day, a robotic mission will reveal the secrets of this intriguing world. Gravity. It's one of those fundamental forces that we often take for granted. It's always there, silently working in the background, influencing every aspect of our daily lives. But have you ever stopped to wonder, what exactly is it? What is this invisible force that keeps us grounded and governs the motion of celestial bodies? Why do objects fall to the ground, and why does the Earth orbit the Sun? These questions have fascinated scientists and philosophers for centuries. Gravity is the force that attracts two bodies towards each other. It's a fundamental interaction that affects everything with mass. The strength of this force depends on the masses of the objects and the distance between them. The larger the masses and the closer they are, the stronger the gravitational pull. It's the reason why an apple falls from a tree, and why we stay anchored to the Earth. Without gravity, life as we know it would be impossible. Sir Isaac Newton was the first to describe gravity in the 17th century. His insights laid the foundation for classical mechanics. He formulated the law of universal gravitation, which states that every mass attracts every other mass in the universe with a force that is proportional to the product of their masses, and inversely proportional to the square of the distance between their centers. This law explained a wide range of phenomena, from the falling of an apple to the orbits of planets. It was a monumental step in our understanding of the universe. But it wasn't until Albert Einstein came along with his theory of general relativity that we truly began to understand gravity. Einstein's theory revolutionized our view of the cosmos. According to Einstein, gravity is not just a force, but a curvature of space-time caused by the presence of mass. This curvature affects the motion of objects, bending the path they follow. Imagine placing a heavy ball on a trampoline. The ball creates a dip, and any smaller object placed nearby will roll towards it. This is a simple way to visualize how massive objects like planets and stars warp the fabric of spacetime. That's a simple way to visualize how massive objects like planets and stars warp the fabric of spacetime. This warping is what we perceive as gravity. So the next time you drop something or gaze up at the stars, remember that gravity is the invisible force that shapes our universe. It's a force that governs the motion of planets, stars, and galaxies. It's the reason we have a sense of up and down, the reason planets orbit stars, and the reason galaxies form and evolve, and ultimately, the reason we are here today. Gravity is not just a force, it's a fundamental part of the fabric of our universe, connecting us all in ways we are only beginning to understand. Detecting exoplanets is no easy task. These distant worlds are often hidden in the glare of their parent stars, making them incredibly difficult to observe directly. Scientists have developed ingenious methods to infer their existence, such as the transit method, where a planet passes in front of its star, causing a slight dimming of the star's light. Another technique is the radial velocity method, which measures the star's wobble caused by the gravitational pull of an orbiting planet. These techniques require precision and patience, but they have led to remarkable discoveries. As technology advances, so does our ability to explore the cosmos. The next generation of telescopes, like the James Webb Space Telescope, promises to revolutionize our understanding of the universe. These advanced instruments will allow us to peer deeper into space and time, capturing images of exoplanets with unprecedented clarity. With each new discovery, we inch closer to answering one of humanity's most profound questions. Are we alone in the universe? Among the myriad of exoplanets discovered, the search for an Earth-like planet is particularly compelling. Scientists are on the lookout for planets within the habitable zone of their stars, where conditions might be just right for liquid water to exist. Finding another Earth is a monumental challenge, but with each new candidate, we gain insights into the diversity of planetary systems and the potential for life beyond our solar system. It's a quest that drives us to push the boundaries of our knowledge and exploration. The universe is vast and full of wonders, and the discovery of exoplanets has opened our eyes to the incredible diversity of worlds that exist beyond our own. From gas giants to rocky planets, each new discovery expands our understanding of the cosmos and our place within it. As we continue to explore, we are reminded that the possibilities are endless, and the journey of discovery is far from over. Who knows what we will find next? The universe awaits.